David Spears, Civil Engineering Instructor at Texas Tech University, talking about CE 2301 statics. We're talking a little bit more about dot products, and this time how they can be used for vector projections, the projection of one vector onto another. Okay, we start with the basic concept of a dot product. It's vector A dot vector B, and we've defined that as scalar values of A and B times each other times the cosine of the angle between them. Gives us a scalar number, just a number, it's not a vector. We have a special case that we're going to use here for projections, where if we dot a vector F with a unit vector U, following this equation up here, it's Fu cosine theta, but the scalar value of u is 1, so it simplifies out to f cosine theta, which we're going to call f projection, the scalar value of the projection. So, as a general example, if we want to find the projection of vector f on line AA, we'll define it down here in an example, use an example to show that. The steps are to find a unit vector in the direction of AA. The direction I can assume either to the right or to the left in this case. It doesn't matter, it'll all come out in the wash. Step 2 is to calculate f projection, the scalar value, which is f, the vector, dot the unit vector AA. Remember, that's a scalar number, it's just a quantity. Then lastly, I want to multiply the scalar value that I get, f projection, times my unit vector, AA, UAA, to get this in a vector form, in a Cartesian form of a vector, which we call f projected vector. All this is easier to understand with an example. This example, I have a vector that's f, and it is in Cartesian form 3i minus 2j plus 2k kips, and I have a line AA. Now I need 2 points on a line to define that line, so for this example, point 1 is negative 17, 31, negative 2. Point 2 is 3, 21, 18. Those are just the XYZ coordinates of it. Okay, first step, find UAA. To do that, I subtract tail coordinate from the tip. So I'm going to say it's pointing to the left. So the tip is pointing at the point 1. The tail is from the direction of point 2. So it's negative 17 minus 3i plus 31 minus 21j plus negative 2 minus 18k. Okay, the unit vector is going to be all those subtracted and added out, divided by the square root of the sum of the squares. So do all the addition and subtraction up here, negative 20i plus 10j minus 20k. Take the square root of all those, 20 squared, 10 squared, 20 squared, the square root of all that's 30. So I can simplify my vector, unit vector AA, down to negative 2/3 I plus 1/3 j minus 2/3 k. That's all these values over 30. Have the step 1. Now step 2 is calculate f projected, the scalar value, which is f, the vector, dot UAA, the vector. So I write out vector f as this format, and write out vector UAA as this. And remember, when I dot product, I just multiply my common terms. I multiply the I terms times each other, j and k times each other. So that's 3 times negative 2/3 plus negative 2 times 1/3 plus 2 times negative 2/3. Do all the math. I get negative 2 minus 2/3 minus 4/3. That's equal to negative 4. Remember, this is just a scalar value that I'm just adding up. Negative 4 kips is f projected. Now, step 3 is convert this into a vector, f projected vector, is equal to the scalar value of f projected times UAA. It's negative 4. I do have units of kips up there. I'm going to keep that. Negative 4 times minus 2/3 I plus 1/3 j, which is just unit vector UAA. Multiply that out. I get this format in the Cartesian format, 2.67 I minus 1.33 j plus 2.67 k kips. Okay, if I'm told that vector f intersects line AA, I can also get the angle theta between the vector and line AA. First I have to, and I'm going to do that just by using this format and rearranging it. F projected is equal to F cosine theta. So, rearranging that, cosine theta is equal to F projected divided by F. Both of those are scalar values. And theta, of course, is the cosine inverse of F projected over F. Okay, I already know what F projected is. It is 4. And it's also the square root of the sum of these components. Note that the square root of the sum of the squares is going to be a positive 4, unlike the value that I had for the scalar value, which is negative 4. Anyway, the square root of the sum of these squares is 4, and I get the scalar value of f, just taking the square root of the sum of the squares of its components, 3 squared, 2 squared, and 2 squared, that's the square root of 17. So theta, the angle between them, is equal to the cosine inverse of 4 over the square root of 17, which is 14 degrees.